So these equations are all in that standard form, the ax squared plus bx plus c form, okay? We're still finding the same pieces, which way it opens, vertex, axis of symmetry, drawing a graph, the intercepts, all those same pieces, only they are in the standard form, okay? All right, so which way does it open? This one opens up, and I know that because the number in front of x squared is positive. It's got a positive attitude, so it's opening up. Vertex. I'm assuming that you do not want to convert it to vertex form using completing the square. So we're going to use our x equals negative b over 2a formula. Notice the a value is 1 because there's a 1 in front of x squared. The b value is negative 6 and the c value is 8. So negative b is negative 6, so negative b will be positive 6 divided by 2 times 1. 2 times 1 is 2, 6 divided by 2 is 3, so the x value of our vertex is 3. It's at 3 comma something. Now how do I get the something? I plug 3 in for x. So I find j of 3. So 3 squared minus 6 times 3 plus 8. Type that in my calculator, or you could work it out by hand. We get negative 1. So j of 3 is negative 1. You put in 3 for x, you get negative 1 for y. So I know that 3, negative 1 is the location of this vertex. I also know it's opening up. Okay. Axis of symmetry will be x equals 3. It's always the x value of the vertex. The domain is always negative infinity to positive infinity. The range, well, if it starts at this spot right here and opens up, then my range is negative 1 up to positive infinity. So bracket negative 1 to infinity. Max or min, well, if that vertex is the low point because it's opening up, then that vertex is a minimum value. So there's a min of negative 1. X-intercept, remember to find the x-intercept, we put 0 in for y. So 0 equals x squared minus 6x plus 8. That's a quadratic equation. There will be 2 answers. Hopefully we can solve them by factoring. X times x is x squared, and 8 is either 8 and 1 or 4 and 2. I'm going to choose 4 and 2 because 4 plus 2 will make the 6 in the middle. They're both negative. Negative 2x and negative 4x makes negative 6x, and negative 4 times negative 2 is positive 8. Okay, if x minus 4 equals 0, that means x is positive 4. And if x minus 2 is 0, that means x is positive 2. So our x-intercepts are 4, 0, and 2, 0. Okay? When I plot those, 4, 0, and 2, 0, yeah, they do look like that's going to make a nice parabola right there. Okay? Y-intercepts. Remember the y-intercept, you plug 0 in for x. So y equals 0 squared minus 6 times 0 plus 8. The y-intercept is actually really nice to find when it's in standard form, because when you work out 0 squared and 6 times 0, that's all going to be 0 and just leave you with 8. So you put in 0 for x and you got 8 for y. So 0, 8 is your y-intercept. What's nice about that being in the standard form is when you plug in 0 for x, this first part always cancels out, and whatever that last value is at the end, the c value, that's going to be your y-intercept. So 0, 8, if I go up here to 0, 8, 5, 6, 7, 8, that will be my y-intercept. And I can finish that graph. Okay? Again, you can graph it in your calculator. And sure enough, when I graph it, it does look the same. X-intercepts at 2, 0, and 4, 0. Vertex at 3, negative 1. Looks like it's supposed to right there. Okay? All right, number 8. Notice this one's going to open down because the a value is negative. The vertex, I'll still do my negative b over 2a. B is negative 4, so negative b is positive 4 over 2 times negative 1. 4 over negative 2, that'll work out to be negative 2. So our vertex is negative 2 comma something. To find the something, I'll plug in negative 2 for x. I find m of negative 2. So negative 2 squared minus 4 times negative 2 plus 1. So negative 2 squared minus 4 times negative 2 plus 1, and I get 5. So when you put negative 2 in for x, you get 5 for y. So the point negative 2, 5 will be our vertex. So negative 2, 5 is our vertex. It's opening down, we said, so that's going to work out. Axis of symmetry, x equals negative 2. The domain is always negative infinity to infinity. Our range, remember this graph is opening down, so it'll be negative infinity up to however high this goes, which is 5. So negative infinity up to 5. Bracket on the 5 because it touches 5. The vertex is a max. It's a high point, so the max is 5. And then our x-intercepts, we put 0 in for y. So 0 equals negative x squared minus 4x plus 1. I don't think this will factor. You can try it, but I don't think it's going to factor. So it is a quadratic. That means there's 2 solutions. Okay? There are 2 solutions. And if we can't factor it, we will find them using our quadratic formula. Remember, the quadratic formula was x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Everywhere there's an a, I'm putting in negative 1. Everywhere there's a b, I'm putting in negative 4. Everywhere there's a c, I'm putting in 1. Okay, so I'll have negative b, so that'll be a 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a is negative 1, times c is 1, all over 2 times a is negative 1. So 4 plus or minus the square root of whatever that part works out to be. So negative 4 squared minus 4 times negative 1 times 1. That's going to work out to be 20. So 20 is the part under the radical. 2 times negative 1 is negative 2. Okay, now we got to think about our radical here. We've got a 20 in there. What are things that multiply to be 20? Well, 4 and 5. And 4 is 2 times 2. There's a pair of 2's, so that means a 2 is coming out. So we'll have 4 plus or minus 2 square root of 5 over negative 2. 2 came out of the radical. 5 had to stay in. Okay. Notice 4 can get divided by negative 2, and 2 can get divided by negative 2. Well, 4 divided by negative 2 is negative 2. 2 divided by 2 is 1. So negative 2 plus or minus 1 square root of 5. Okay, so our x-intercepts, one of them is negative 2 plus square root of 5, comma 0. The other one is negative 2 minus square root of 5, comma 0. Okay, those are what we call the exact answers to those x-intercepts. Now, I don't know about you, but negative 2 plus square root of 5, I don't know what decimal that is. So in your calculator, if you type negative 2 plus square root of 5, you get about 0.23. So one of my x-intercepts is about 0.236 or 0.24, comma 0. And the other one, negative 2 minus square root of 5, I get negative 4.24, comma 0. So we can kind of estimate that. 0.24 is just barely over on the positive side here, whereas negative 4.24, there's negative 4, negative 4.24 would be about right there. So when it opens down, it is going to touch those 2 points. But Connect Math is going to ask you to type those x-intercepts in this way, as ordered pairs. Okay? So just know, if you don't have a perfect square number under that radical, the decimal values of your x-intercepts is where you'll estimate the graph, but Connect Math is going to want exact, and so you would leave it in the radical form. And then the y-intercept, remember that value at the end is always our y-intercept, so 0, 1. If you put in 0 for x's and simplified it, you would still get 1. So 0, 1 is that y-intercept. And I can sketch that graph right there. Okay? In your calculator, if you graph it, and sure enough, if you'll notice, it touches the x-axis just barely past 0, like my graph does here. and then just barely to the left of -4 is where it touches the x-axis on the other side. So the two x-intercepts are right there, okay? Last one here. Which way does it open? Opens up because our a value is positive. Vertex, -b over 2a. So -5 over 2 times 1, which is going to work out to be -5 divided by 2, -2.5. I think -2.5 is easier to work with. It's better to use a decimal, but you could have called it -5/2. Okay, that would be the same thing. And then when you plug that in, p of -2.5, you get -2.5 squared plus 5 times -2.5 plus 6. So -2.5 squared plus 5 times -2.5 plus 6. And I got -0.25. So my vertex is -2.5, comma, -0.25. Okay, and you have to kind of estimate where those are on your graph. -2.5, and then down to -0.25. Kind of estimate where that is. Okay. Axis of symmetry is always that x value number. That's the little imaginary vertical line that cuts it in half. Domain is always -infinity to infinity when we're dealing with quadratics. The range, well, here's our vertex and it opens up. So remember, started from the bottom, now we're here. It's going to start at -0.25 and then go up to infinity since this one opens up. The vertex is a minimum value. That minimum value is -0.25. That's the lowest that the graph goes. X-intercept, we put 0 in for y. So 0 equals x squared plus 5x plus 6. Okay. You can try to factor this. I think it will factor. Let's see. X plus 3. Yeah, x plus 3 and x plus 2. 3 times 2 is 6, positive 3x and positive 2x will make 5x in the middle. Okay. If you had trouble factoring, you could do quadratic formula. That would work as well. All right, so if these two things multiply to be 0, then either x plus 3 equals 0 or x plus 2 equals 0. Subtract 3 from both sides and you get -3. On this equation, if you subtract 2 from each side, you get -2. So our x-intercepts are -3, 0 or -2, 0. Okay, so if you put in -3 into this equation, it solves it. If you put -2 into this equation, it solves it. Because the graph hits the x-axis twice, at -3 and at -2. Y-intercepts, you put 0 in for x. So y equals 0 squared plus 5 times 0 plus 6. You're going to get 6. We knew we would get 6 because that was our c value at the end. So when they're in standard form, that c value at the end is your y-intercept. So 0, 6 is the y-intercept. So this graph will look like this. And of course, you could verify that in your calculator. Okay. Trickiest part of this probably is finding the x-intercept. Okay, remember the x-intercept, you find those by putting 0 in for y. Okay. Anytime you have a quadratic equation, there should be 2 x-intercepts. You're going to have a quadratic equation set equal to 0, which is why we practice that in our developmental support material. You will get 2 answers because the graph should hit the x-axis twice. We will see some examples a little bit later in the chapter where you end up with a negative number under your radical here in the quadratic formula, and the answers work out to be imaginary. When that happens, then what happens on your graph is your vertex is above the x-axis and it opens up, or your vertex is below the x-axis and it opens down. So if the graph does not touch the x-axis, that would lead to imaginary values when you solve your quadratic equation. Okay, that's the only time that you would get imaginary numbers. A negative number under your radical means the graph does not touch the x-axis. But otherwise, there should be 2 times that the graph hits the x-axis.